Desktop audio. Okay. There we go. Hello. Who is Jordan? Okay. If you're asking a question, I've checked over all the tests, I'm about to do the grades and return them. So you'll get them today. We do need to review a concept that I feel is a pretty common problem. Wasn't exactly everyone had the issue, but a lot of people had the issue. You're not here, oh, okay, how would you? Okay, hi Marsha. Hi Ezra. So we got 6 of you, we got 5 of you. I don't know which 5 we have, but we have 5 of you. So 2 of you have not commented. Or maybe Wunju has 3 new accounts. That'd be amazing. Wunju with the 3 new accounts. Okay, I've graded the tests, and so I'm gonna give you return them today. For the most part, they were all right. They weren't our best, but I think a lot of people struggled on certain concepts that were reviewed, so we're going to review and review concepts. And yeah, people did generally make mistakes. Actually, the last question almost no one got wrong. So for the most part, you guys all know distance and midpoint formula. Triangles are still interesting, and yeah. So we won't talk about that. So we're going to talk about chapter 12, and this is going to be the last full chapter. Chapter 13 will only be part of it. So yeah, chapter 13 will only be part of it. Oh, you're having a Zoom meeting. How much of your class is having a Zoom meeting? How many of your class are having a Zoom meeting? It was my question, Bogo, not yes or no. Anyway. Okay, well, I'll teach the lesson anyway, and then people can ask questions on the homework or something like that. Okay, before we begin, one of the things I know we need to review. Oh, it's still wet. Okay. Before we begin, we need to review polynomial multiplication because it is important, and I don't want you guys to this concept right here is squared. Now the issue we have here is that some people think this is the same thing as this. That is, that definitely makes sense. Okay, so some people mistake this. This is this whole thing squared. So it's actually just x plus 2 times x plus 2. Okay, which you then FOIL, and you get x times x, x squared, x times 2, 2x, 2x, and 4. So you get your answer here is x squared plus 4x plus 4. Okay, this is widely different than this, where you square each term. So you square the 2, you get 4. You square the x, you get x squared. So this concept is only for multiplication, and this is when you have addition, okay, or subtraction. Okay. Why are we reviewing Woodrow? Because so many people made mistakes on this. So many people made mistakes on this. Okay, didn't we learn this before? Yes. In fact, we're going to keep learning it until we get it embedded in us. Okay, so that's we're going to go in more depth of this later, and I will give you a homework assignment to remind you of exponential rules, because you'll need to know them for this chapter. We're on chapter 12. Chapter 12, section 1. Hi, DK. Oh yeah, I was supposed to say hi to DP and I think Remix is Sam. Okay. Where's Remix? Mateo. No, Sam. Yeah, I don't remember who Remix is. It's weird when you don't have your name. Okay. So 12.1 is about its inverse variation. Okay. Now, inverse, if we just take the words, okay. So we're not gonna look at the math. Well, I have remind myself what lead names are. Goodness gracious. So inverse variation. Okay, inverse means we're gonna have opposite, or yeah, kind of opposite. We'll say opposite for the sake of opposite, and variation means change. Okay. So opposite change. Yeah. See, I said remix with Sam, and then I was like, but you know, Mateo also has a weird name on this, so you know, you both have the same strange names in my brain. Okay. So inverse variation. Okay, we're gonna look at the basic form. The basic form is y equals 1 over x. Okay. Or this would be x, y equals 1. So either of these is inverse variation right there. Okay, this is inverse variation. Okay, so if you have x times y, you're going to get inverse variation. And if you have y equals 1 over x, inverse variation. What do I mean? Okay, well, let's plug in numbers for x. Let's erase our inverse variation up here. Let's erase our formula. Okay, so let's just take x, y. Let's have negative 3. No, we'll do negative 2. Yeah. Negative 2, negative 1, 1/2. There's a reason why I'm doing this. 0, 1, and then 2. Okay. We might need to move it. No, I guess okay. 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 So inverse variation means what we plug into this will change our y. So if we plug in negative 2 here, we get y equals 1 over negative 2. So y equals negative 1/2. And if we plug in negative 1 for x, y equals 1 over negative 1. Same thing as negative 1. And if we plug in 1/2, y equals 1 over negative 1/2. This denominator is going to switch. So we're going to get y equals 1 divided by negative 1/2. What's 1 divided by 1/2? Well, that's negative 2. Okay? Hi, Jackson. Okay, what about 0? Can we plug in 0 for y? Y equals 1 over 0. Well, how many times does 0 go into 1? We don't know. So this is going to be undefined. Okay, and actually a rule is if you have a 0 in the denominator, it's always going to be undefined. Okay, we're not going to know what point that is. Okay, and then if we plug in 1, so all we're doing is just plugging in into this function, y equals 1 over x. We're going to plug in numbers. So plug in 1 for y, x, we get 1 over 1. And if we plug in 2, y equals 1 over 2. So 1/2. Okay, now I want you to notice something. Notice right here, these two. What happened? Okay, when x was -2, y was -1/2. What happened when x was -1/2? Y was -2. So these actually will switch values. So it makes it easier to predict what's going to happen, especially with regards to the x and y. So if you know the x point and y point, if you can switch those, you'll also find the second point. Okay. Now the graph of this will actually be will actually look something like this. Okay, so it looks something like this. Yeah, you could say UND. I'll allow it. Okay? So it looks something, the graph will look something like this. Now, guys, I know we don't like graphing, but honestly, after 12.2, we won't have graphing again. Yes, that's our last graphing. Okay? So 12.2 is our last graphing. Okay? Yes, on inverse will almost always look something like this. Okay? Now notice, guys, does the line cross the x and y axis? No. Okay? So the line does not cross the x and y axis. So for this, y and x, it doesn't cross these two axes. Okay? Okay. Yep, for the year. For the year. No more graphing after that. Okay? Okay. Well, in inverse variation, so let's we'll come back to graphing. Okay? There's a few more things, but we'll come back to graphing. If you add 2 more spaces to the graph, once you get 1/2. Yes, exactly. Yep. Ezra, you are correct. So, constant, if we have, this is our formula for inverse variation. Inverse formula. Well, let's actually double check. I don't want to lie to you. If 12.3 is graphing, I'll figure out something so it's not going to be graphing. Because I don't want to be lying to you about how much graphing you have left. Oh, yeah. Yeah, we're not going to do graphing at 12.3. No, we won't. We're not going to do that graphing. So yeah, 12.2 will be the last graphing. Okay, so inverse formula. If you have A up here, A is going to be, is the constant of variation. Okay. And what that means is that constant just means a number. So it is the number that determines the change. Okay? So constant of variation literally means the number that determines the change. So it doesn't mean that this number is changing, but that it affects how our x and y are going to change. Okay? So the constant of variation means that affects our x and y connection. Okay? So what does that look like? So what does that look like? Well, okay, I want to show you two things. Okay, if we're in this position and I multiply both sides by x, okay, these two cancel, right? And then this just becomes xy equals a. So these two formulas are the same. So these both are inverse variation. Okay? Okay? And inverse variation means as one goes up, the other has to go smaller. So as one gets, think of it, inverse variation is basically a seesaw. Okay, you got your y over here and your x over here. And so as x goes up, y has to go down. And in the opposite case, if y goes up, x is going to have to go smaller. Okay? So this is our inverse variation formula. And our a is this thing that balances it out. So whatever a is going to affect how big or small something is going to be. Okay? Okay, let's look at some problems. Now, the first step is identifying. Can we tell what inverse variation, direct variation, or not? Direct variation, think direct. What does direct mean? It means straight, okay? Direct variation means straight variation. What's that mean? That means as one variation. And the reason why we're doing that is we are only, sorry, I'm buffering. I should turn off my phone because it could be that we have a rare case of too many people here. Yeah. Okay. Sorry. If it's not working, just let me know. Why are there two lines on inverse? Well, inverse, we're going to have it broken up. So it can't cross when x equals 0. It can't equal that. Also, we don't understand when y equals 0. So basically, that's going to separate out our graph. It's going to break it into two. Okay? Okay? Direct variation is going to be when you have some line, straight line, that crosses through the origin. Okay? It just crosses through the center. Okay? So, a can be any number for either of these, except 0. Okay? So a is any number, just not a doesn't equal to 0. Okay? That's the only rule. So let's look at some cases. Okay? Now, I'm also not wanting to do a word problem today because there's graphing. And I learned my lesson from last chapter, because we won't do as many graphing questions on a homework assignment. That was crazy. Okay, so let's see whether this is direct, inverse, or neither. Neither just means you have addition when you shouldn't have addition. Okay? Now this one right here, it's in the form x times y equals 4. So if you see x times y equals something, that is going to be inverse. Okay? Or you could change it by dividing both sides by x. If we divide both sides by x, cancel the x's, we get y equals 4 over x. And that's our format that we really should be familiar. We should start getting familiar with. We aren't familiar, we'll get familiar with. Okay, this one looks like it's this, looks like an inverse, except if we multiply by 2, which we're allowed to do, multiply both sides by 2, we get y equals 2x. Y equals 2x. Now what format is this in? This is direct, right? X and y are equal parts, so this is direct. Now we see this plus right here. What does plus change? Well, plus means this is not going to be either. It's not going to be inverse or direct, so it's neither. Now, is this a line right here? Yes. So this is a line. This is a line. But direct means that there is no other thing besides y and x. Okay? And something multiple. So the answer, oh, sorry. The answer is the inverse. This is the answer. This is just me formatting it. So the answer is this, direct. Okay, so you box those. Okay, that's a pretty easy question right there. You just box the part. Okay? Okay, let's look at some examples. All you have to do is tell me which one is direct, inverse, or neither. Okay? Direct, inverse, or neither. Okay? Now let's look. Y equals 2 over x. 4y equals 3x. 5x minus y equals 3. And xy equals 1/2. So this is 1, 2, 2, 3, and 4. Tell me which one's inverse, direct, or neither. Okay? Tell me which one's which. That you can't see. You can't see what? Is it frozen? Oh, it doesn't show the top. That doesn't make sense. Here. There we go. Okay, so tell me what is the answer. Direct, inverse, or neither. So for number 1, number 2, number 3, and number 4. So Ezra says 1, 3, and 4 are inverses. What's number 2? Okay. Okay. So 1 should be the most straightforward, because you have y up here and x equals something over x. So this is going to be our inverse. Okay. Okay. Now this one has y and x, but neither of them is on the bottom. So if you just divide by 4, this is going to equal y equals 3 over 4x. And that is going to be direct. Okay. Now this one has a minus. So we have 5x minus y equals 3. Now notice that this is 3 by itself. That's going to mess us up if we think it's direct, because direct shouldn't have any plus. Inverse also doesn't have any plus, so this is actually going to be neither. Okay? If it didn't have this 3, if it was 0 here, this would be, if without this 3, this would be direct. Am I losing the internet again? No. Okay. Okay, well, then, so we have inverse, direct, then neither, and this one is x times y, which is, as we know, inverse. Okay? Sorry. Yes. Ants. In Indonesia? No way. Okay, so we have our 4 categories. Okay, I have 3 categories for 4 questions. Okay, so let's go to graphing. Okay, I zoom in on this. Actually can. Oh, there we go. Okay. That won't necessarily be the most clear, but it will actually be legible. Okay, we're going to graph y equals to 4 over x. Okay, y equals to 4 over x. So how do we graph this? That's an excellent question. What we're going to do is make a table. Now we're not going to compare this to the original or anything like that, but what we are going to do is I'm going to show you just the basic. They kind of have 2. We're going to just look at a very basic one. Okay, x and y, and I'm going to plug in -4, -2, -1, 0, which we kind of know, 1, 2, and 4. Okay, so, sorry, it hit curves at the end. I was trying to make sure it wouldn't go too far. Okay, so is there extra number? Yeah, that's true. That's okay. There's an extra number. It is it's going to be neither. Okay, so I'm going to plug in -4 in for x. Okay, what's 4 divided by -4? Well, that's going to be, so 4 divided by -4, is going to equal negative 1. What's negative 2? So 4 divided by negative 2. Well, that's going to equal negative 2. And then what's 4 divided by negative 1? It's negative 4. 0 is going to be undefined, because we can't put a 0 on the denominator. 4 divided by 1 is just 4. 4 divided by 2 is 2. 4 divided by 4 is 1. So notice, there's opposites, okay? Why did I pick these values that are factors? Okay, choose x values that are factors, okay, of a. So if a is 4, yeah, I know. Keep buffer. I don't know what to do. Here I can try to close more things. I think it's going to change much. No. The main part that's necessary is this table. The main part that's necessary is the table. You don't have to do the y equals. That's just so that people know I'm dividing it and not doing it in my head. Okay, so graphing this. So we go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. So we get positive 1 is 4 up here. Plus 2 is 2. Positive 4 is 1. Plus negative 4 is 1. 2 is 2. It should be right there. Now, does the book give more points than this? Yeah, it does. But we don't need to give all those points. That's too many points. Yeah. So in this case, in this one, because the top is positive, we're going to be in quadrant 1. Sorry, quadrant 1 and quadrant 3. Okay. We're going to be quadrant 1 and quadrant 3. You don't have anywhere to set the table. Okay. Just make sure you've plotted the points and connect the points with a smooth curve, and you should be good. Okay. Okay. Do they compare the graph? No. Okay. So, I don't know why it's loading. Or why is that internet right now? Just do this. Okay. So, I think that will help us. Okay. It might not be ideal, but it's going to be what I have to deal with. Okay. So the thing we're going to do is going to be in the quadrant 1 and quadrant 3. Okay, positive is going to be quadrant 1 and quadrant 3. Yeah? No, you don't have to say what quadrant. That's just me explaining the next part. That's I explaining. That is just, so it'd be me. Okay. So what about negative? Well, if we're graphing y equals negative 4, over x. We can actually still use the same points of x. So we can do -4, -2, -1, 0. You don't have to use 0, but yeah, 2 and 4. Okay, so plug in -4, so we get -4 over -4, which gives us 1. I'm just showing the work so that you see. Divide by -2, we get 2. And divide by -1, and we get 4. This is still undefined. Divide by 1, we get -4. Divide by 2, we get -2. Divide by 4, we get -1. So our graph is going to be in quadrant 2 and quadrant 4. Okay, so quadrant 2 and quadrant 4. Okay, so negative is going to be in quadrant 2 and quadrant 4. Okay, you have to fill with quadrants? No, you do not. That is the graphing. Okay, so all we need to do is examine and graph and find. This is our last step. Okay, very short lecture. Hi, Dan. Glad you can join us. You might have to rewatch it because it's kind of further. So, okay. So we're going to example 4. And before we go into example 4, whenever you have a graph where two parts are separated, like what we just had, like this, okay, something like this. This is called a hyperbola. Hyperbola. And it is actually a really special kind of function. You don't have to put the 0. No need to put the 0. Okay, a hyperbola. Each of these separate parts are called branches. So this is a branch, and this is a branch. Okay? It's almost like there's a tree here, and these are the two sides. Okay? Now, hyperbolas have so many other formulas, but there's 2 things we need to know. First, we need to know that this line right here that we don't cross, you see how this line we don't cross it? That's actually called an asymptote. Asymptote. Okay? And up and down is a vertical. So up and down as we approach x equals 0. And this, we're not going to cross the x-axis, which will be a horizontal asymptote. Okay? And asymptote, for all purposes, is something we don't reach. We can't touch it. Okay, so we can get close, but we can't get all the way there. Okay, think of it as this horizontal aspect. We can get closer and closer and closer, 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 closer. Not going to touch this line. Okay. Now there is a better definition, but for now, this is all we really need to know. Plus, this is actually way beyond the level you would be at in most math classes. Okay. Now, granted, could you have learned this on your own and been far ahead? Yeah. Today, that's all we're going to do. Okay. Now, when we say something like this, the variables x and y vary inversely. Okay, this means we are actually dealing with inverse variation. And so when they say and y equals 6 when x equals -3. Well, what they mean is we have x and y equal to some number a. Okay, could you do the y equals a over x? Yeah, these two are the same thing, but this is easier. So we're saying this is easier. Okay, not that it's wrong or right, it's easier. Do we have to write the numbers on the graph? Yes. Yeah, you should. That was just me being a little bit lazy there. Sorry. Okay, now what we need to solve for is we're going to find out what is our a. Okay, what is our a? That's what we're trying to find out. So they gave us 6 and -3. So we're just going to plug that in. -3 for x, 6 for y equals a. So -18 equals a. So if you have your formula, we could just plug this back into this formula. We get y equals -18 over x. Okay? And then they say, find y when x equals 4. Well, what do? We just plug this 4 in for x. So y equals -18 divided by 4. Simplify it down. This is a 2. This is a 9. So y equals -9 over 2. And there you go. That's your two answers. So your two answers are here and here. Okay? That's all you have to do. Okay? So it's easier to start with x and y equal some number a, and then solve it. We're basically done. We're almost done. Just maybe one more question, and then we'll go on. Yeah, basically done. Yeah, I feel like that's a good start. Okay, guys, so thank you for joining. I'm sorry for the internet connection issues. I think tomorrow we'll have a better connection and better. So Friday will be our next lesson. We'll be done with it today. We will have some review questions in this homework. This is a pretty straightforward in terms of how many things we're going to do. We're only doing 3 types of questions. We will have some review questions on the homework. So each homework is going to have review questions for previous chapters. The reason behind that is because we do not have a final. So since we don't have a final exam, we are going to review the sections that are most important for your upcoming years. The other thing is, we're going to finish technically May 15th with some statistics stuff, which I think is really important. But I want to make sure that you guys are prepared for geometry. So I'm going to give you guys some stuff that you can do over the summer if you want to prepare better for geometry. You don't have to do it. It is just to make sure that when you go into geometry next year, you're not overwhelmed by the workload or how you need to solve proofs, but you kind of have a standard idea of how to do it. Okay? Okay. Thank you guys so much for joining. I appreciate all of you. I hope you all had a great break. We don't have a final exam, so So instead of final exam, we're going to do review exercises. Okay, thank you guys so much for joining. Friday at 9 we'll begin. If you have a Zoom call, please let me know. I will try to reschedule if need be. But yeah, we'll do our class at 9 on Monday, Wednesday, Friday. So next week, Monday and Wednesday. And the week after that, Monday, Wednesday, Friday. Okay? Thank you guys so much for joining. You have a wonderful day.